Hello, this is part 4 of derivatives practice problems. So I think this is the final part for practicing derivatives. So let's start with number 1, and there's going to be 5 questions for this video. Find dy dx if x cubed minus y cubed equals y. So what we're doing is we are implicit differentiation. So if you forget how to derive implicitly, or if you forgot how to do a step, go ahead and review my video on implicit differentiation. Okay, so let's look at our equation. We have x cubed minus y cubed equals y. So we got to take the derivative in respect to x. So the derivative of x cubed, so there's how many terms? There's 1, 2, 3. There's exactly 3 terms. So let's take the derivative of x cubed. The derivative of x cubed in respect to x would be just power rule, so it'd be 3x squared. And then you have an option of putting dx over dx because we are taking the derivative in x. But here's the thing, dx over dx cancels, so it's just 1. So you don't have to put dx over dx if you wouldn't like. Okay, so the derivative of y cubed is negative 3y squared in respect to x, so it would be dy over dx. And then the derivative of y is just 1 dy over dx. Okay, so now we have to just get dy dx by itself. So what I would do is get anything with the dy dx on one side and anything that doesn't on the other. So let's move this whole thing to the right because it has a dy dx. So it's 3, you're going to add 3y squared dy dx. Okay. Now I'm just going to rewrite it. I'm going to switch this to the left because you can do that because of the commutative. So you can write this as 1 dy dx plus 3y squared dy dx. And then on the right, it's just left with 3x squared. The dx cancels, so you don't have to worry about that. And then on the left side, what can you take out? A dy dx. So that's why I put it all on one side. So it's going to be 1 plus 3y squared equals to 3x squared. And then to solve for dy dx, you can divide both sides by 1 plus 3y squared. Okay, so your final answer will be dy over dx equals to 3x squared over 1 plus 3y squared. Okay. Let's move on to question 2. Find dy dx if x squared minus 16xy plus y squared equals 1. So this one, you do need a little bit of product rule because the derivative of x squared is easy. This one you have to take the product rule, and then this one's easy. And then on the right side, the derivative of a constant is always going to be 0. So yeah, so let's take the derivative of x squared. So derivative of x squared in respect to x would be 2x dx over dx. The derivative of this entire thing, well, I am going to use the product rule, but first I will factor out that minus 16. And then just take the derivative of this inside the bracket. So my f is going to be, so product rule is f prime g plus g prime of f, right? So f is x, f prime would be 1, g is y, g prime would be 1, and then because we have to take it in respect to x would be dy over dx. So it's going to be f prime, which is 1, and then g is y, plus g prime, which is 1 dy over dx, and f is x. So that would be y plus x dy over dx, right? And then we do have to FOIL, we took out a negative 16, so FOIL that out. So FOIL that out, and so this would be negative 16y minus 16x dy dx. Okay. So here, let me write it out here. So we have a 2x, dx cancel, so you just leave that alone, and then you have a minus 16y minus 16x dy dx equals, oh, and then the derivative of y squared in respect to x is, what is that going to be? It would be 2y dy dx equals to 0. Okay, just like the other problem, anything that has a dy dx, get it on one side, anything that doesn't, move it on the other side. So this 2x and then this negative 16y does not have a dy dx, so move it to the right. So I would add 16y. And then I'm going to subtract 2x. So you're going to get, let's see, negative 16x dy over dx plus 2y dy over dx equals to 16y minus 2x. And then factor out a dy dx. So that would be negative 16x plus 2y. And that's going to be 16y minus 2x. And then get rid of this by dividing both sides by negative 16x plus 2y. So I get dy over dx equals to 16y minus 2x over negative 16x plus 2y. You can't cancel these out because this is a 16y, this is a 16x. So what we could do is take out a 2. So if I took out a 2 on both numerator and denominator, this would be 8y minus x over, and on the bottom, if I take out positive 2, this would be y minus 8x, or negative x plus, negative 8x plus y, the same thing. So what cancels the 2? So your final answer can be expressed as dy over dx equals to 8y minus x over y minus 8x. Okay. Let's move on to question 3. So this time, find dy dx at a point of 2, 1 if x plus y over x minus y equals 3. So this looks a bit difficult because you have a point and then you have like a quotient, but do it implicitly, but do not on the left side, do not do the quotient rule. It looks tempting to do the quotient rule, but you can actually do something simpler. You can actually cross multiply, because this 3 has a denominator 1. So if I cross multiply, it would be x plus y equals to 3 times x minus y, right? And then from here, I would FOIL off this 3. So this is 3x minus 3y. And then over here, this is x plus y. And just take the derivative. Wait, no. Then what I would do is get all the x's. I would try to get y by itself. So Yeah, so I'm going to subtract 1x from both sides. So I get y equals 2x minus 3y. And I'm going to get all the y's on one side, so I'm going to add 3y. And move this, yeah, I'm going to add it. So I get 4y equals to 2x. Then get y by itself. So I get 2, so the 4. Then take the derivative implicitly. The derivative on the left side would be 1 dy dx. And then the derivative of 2/4 x in respect to x would be 2/4 dx over dx, which really just cancels. And then, yeah, we didn't actually have to use the point. We didn't have to plug in the 2, 1 because remember a slope is a number, so, or a constant. So dy dx is going to be 2/4, which can be reduced by 2, which would be 1/2. Okay, let's move on to question 4. Yeah, that looks a little complex. But if we do this carefully, we probably won't make a mistake. So what would I? So we have to find dy dx if x times sine y plus y times sine of x equals pi over 2 radical 2. Oh, and then also they tell us one more thing at the point at the coordinate pi over 4 comma pi over 4. Okay, so you're just gonna have to apply the product rule. So the right side it's easy because the derivative of this is a number, and then the derivative of a number or constant is always going to be 0. So that's good. Now over here, let's just take the derivative of this. So you do have to use the product rule. So if f is x, f prime would be 1. If g is sine of y, g prime would be cosine of y, and then you have to add a dy dx. So if you take the derivative of that, this would be wait, so let me write this out. So the derivative of x sine y is going to be product rule. So f prime of g plus g prime of f. F prime is 1 times g, which is sine of y, plus the g prime, which is cosine of y, dy over dx. And then f is x. Okay, so that would, if you clean that up, you can rewrite this as sine of y plus x cosine of y dy over dx. Okay. Now let's take the derivative of this thing. So if f is going to be y, f prime would be 1 dy over dx, right? And if g is going to be sine of x, g prime would be, the derivative of sine of x is the derivative of sine of x is cosine of x. And then you could put dx over dx, but that cancels, so you can leave it like that. So the derivative of y of sine of x is going to be product rule. So f prime is 1 dy dx. And then yeah, 1 dy dx times by g, which is sine of x plus g prime of f. So this would be that would be just y times cosine of x. Okay, so so on this side, when you take the derivative of this, that would be, it would turn out to be sine y plus x cosine of y dy over dx plus sine of x dy over dx plus y of cosine of x. And then the derivative of pi over 2, it's a number, a constant, so it's going to be 0. Okay, so just like the other problems, we have to get dy dx, and then anything that doesn't have a dy dx, we get it on the other side. So this doesn't have a dy dx, this doesn't have a dy dx. So move it to the right, so we're going to subtract y cosine of x. And then subtract sine of y. Okay, so on the left, so this cancels and this cancels. So you could take out a dy dx. That's the whole point of it. And then this would be x cosine of y plus sine of x. And then this was going to be, the right is going to be minus cosine of x minus sine of y. And then to solve for dy dx, you're going to have to divide this both sides by this. So dy dx, so this cancels, and then you're left with minus y cosine of x minus sine of y over x cosine of y plus sine of x. Now, before I plug in our point pi over 4 and pi over 4, what could you do? On the numerator, what could you do? Wait. You could actually, what could you do? You could factor out minus. Yeah, so you could factor out a minus. So this would be minus bracket y cosine of x and then this would be plus sine of y over x cosine plus sine of x, right? And then what you could do is plug in the point. So dy dx of the point pi over 4 comma pi over 4 would be minus, and then this would be, my y value is pi over 4, and then it's going to be cosine of pi over 4 plus sine of pi over 4, and then this would be pi over 4 times cosine of pi over 4 plus sine. So what do you get? They're practically the same thing, right? The numerator and the denominator are now identical. So this cancels, so you're just left with this invisible -1. So your final answer will be dy dx at the point pi over 4, comma pi over 4 is going to be at -1. Okay, last one. Okay, so we have to find the second derivative. We have to find the derivative implicitly twice. So it's going to be, we have x squared plus 4y squared plus 1. So let's find the first derivative implicitly. So this would be dy dx equals to 2x plus 8y. Oops. Here, don't put, just write, so this would be the derivative of x squared is 2x plus 8y dy dx. Now the derivative is 1 and 0. And solve for dy dx. So you're going to subtract 2x, you get 8y dy over dx equals to -2x. Then divide this by 8, you get dy over dx equals to 2 and 8 can be reduced by 2, so that would be negative x over 4y. Okay, now we have to take it again. So we have to take the derivative of this by using quotient rules. So quotient rules f prime of g minus g prime of f all over g squared. So our f is going to be -x, f prime is going to be -1. You have the option of putting dx over dx, but that cancels. And then our g is 4y. The derivative of g prime would be 4 dy over dx. And just apply the second derivative. So it's going to be d squared of y over dx squared equals to -1. I'm just applying the quotient rule, -1 times 4y minus bracket 4 dy dx times it by -x bracket over g squared. So that would be 4y squared. So this is -4y. And then when you FOIL this out, so 4 times -x is -4x. And then you have okay, so it's when you have a minus and a minus, so that's going to be positive 4x dy over dx all over 4y squared is 16y squared. Now this dy dx, we can substitute that value. We said that in our previous dy dx is -x over 4, -x over 4y. So you can replace that. So that would be 4x times dy dx, which is -x over 4y. And the 4's cancels. And then when you clean that up, that would be -4y minus x squared over y all over 16y squared. If you simplify the numerator, right, you have a complex fraction. So if you simplify that, this has a denominator of 1, right? So this, if you multiply this by top and bottom by y, so that would be -4y squared minus x squared all over y divided by 16y squared. And when you clean that up, when you clean that up, it's going to be, your final answer is going to be -1 over 16y cubed. So I guess that wraps it up for this section. Thank you. Have a good day. Bye-bye.